Okay, let's unpack this. Imagine a world where the monumental task of creating these incredibly complex 3D experiences, whether it's a groundbreaking new video game or maybe a hyper-realistic scientific simulation or even virtual training for, say, aerospace engineering. What if that wasn't a months-long, resource-draining battle with some fixed monolithic engine?
Right, like the ones we're used to.
Exactly. What if you could just sort of declare your creative vision or your technical vision, outline your precise needs, and then, almost like magic, an intelligent system builds a custom-tailored engine perfectly optimized for your project in just hours?
It sounds almost too good to be true, doesn't it?
It really does. And today, we're diving deep into exactly that, the revolutionary Cadence platform, and crucially, how the powerful Tellusim technology acts as its high-performance backbone, really enabling this vision of incredibly fast, customizable, and AI-driven 3D creation.
What's truly fascinating here, and I think this is a profound shift, is that we're moving far beyond the traditional model, where you just choose between a handful of existing kind of one-size-fits-all engines.
Yeah, picking the least bad option sometimes.
Pretty much. Instead, we're stepping into an era where you can actually generate and continuously evolve entirely bespoke engines. It's much more like how you'd manage infrastructure as code. Yeah.
Okay, I see. So the engine itself becomes code.
Exactly. Your engine isn't just a tool anymore. It's this intelligent, adaptive entity built precisely for your unique project. And the mission of this deep dive today is really to illuminate how this powerful blend, this mix of AI orchestration, declarative design, and underpinning it all, a cutting-edge rendering substrate like Tellusim, how all this is poised to, well, democratize and dramatically accelerate 3D development across virtually every digital domain you can imagine.
Exactly. So yeah, get ready for some serious aha moments as we peel back the layers on this. We'll explore how this tech drastically shrinks the time from concept to working prototype, how it empowers creators with, frankly, unprecedented agency over their tools, and how it's laying the groundwork for truly self-evolving interactive systems. Systems that adapt and improve all on their own.
It's a fundamental change in how we think about building these experiences.
Right. So let's set the stage. For years, we've seen the undisputed reign of these giants in 3D development, engines like Unreal and Unity. They are incredibly powerful, no doubt, but they're also, as you said, rather titanic. Huge. They offer extensive pre-built systems, comprehensive tools, a vast ecosystem. Yet this often comes at a significant cost, right? A trade-off. Flexibility, sometimes performance, or even just understanding what's going on under the hood, transparency. You often find yourself forced to mold your unique vision to fit their pre-existing frameworks, which, let's be honest, can feel less like creation and more like wrestling with this enormous, unyielding beast. What does that actually mean for a developer day to day?
That's a really astute observation.
Yeah.
And it raises that important question. Why does this limitation persist? Why are we stuck with this? And it fundamentally stems from their monolithic nature. Picture like a massive, intricately designed Swiss Army knife. It's got tools for almost everything, sure.
Right.
But if you need a very specific, custom-made blade that isn't included, you can't just easily swap it in. It's all fused together.
Yeah, you're stuck with the factory default.
Exactly. Developers often find themselves spending weeks, sometimes even months, just wrestling with the initial engine setup.
Yeah.
Configuring complex pipelines, trying to understand undocumented quirks, just to get started, before they even write a line of game logic.
Wow, weeks or months just on setup.
It happens. And then customizing internal components, making deep-seated changes to the core engine to fit a highly specialized need. So you need a bespoke rendering path for a unique art style, or a physics system tailored for, I don't know, microgravity environment.
Right, something really niche.
That's a huge, time-consuming, and often incredibly frustrating endeavor. Our source material really highlights how the blistering pace of real-time graphics innovation, it's actually outpaced the inherent modularity of these legacy engines.
So the engines haven't kept up with the graphics tech.
In terms of modularity, yeah. This means attempting to use them across vastly different domains, like adapting Unreal for an ultra-high precision medical visualization needing perfect anatomical accuracy versus its primary use case in a fast-paced action game.
Very different needs.
Totally different. It often just devolves into this complex patchwork of workarounds, hacks, constant compromises. It's this continuous struggle for developers. Do you prioritize absolute control, or do you choose the path of least resistance and accept the engine's complexities?
Speed versus flexibility.
It's exactly in speed with pre-built stuff versus fighting for the flexibility to achieve your exact vision. It's this perennial battle. Your ambition versus the vendor's constraints.
And it's not just the gaming industry feeling this crunch, right? You think about the vast simulation sector, aerospace, defense systems, advanced medical imaging, drug discovery.
Critical fields, yeah.
These industries have an urgent, sometimes life or death need for real-time rendering. But they often lack access to platforms that are truly adaptable to their unique, often very stringent requirements. They end up in these underserved niches trying to retrofit tools that just weren't built for their specific challenges.
Precisely. The inherent rigidity, the generalized nature of traditional engines, it severely stifles innovation in these mission-critical sectors. The source vividly described how engineers, researchers in these fields, they're frequently constrained, stuck choosing from a very limited menu of one-size-fits-all engines.
Which limits what they can even attempt to build.
Absolutely.
Yeah.
It significantly restricts their creative and technical agency. They just can't build with the precision and specificity they require. This leads to suboptimal solutions, inflated development costs, or these massive, incredibly expensive customization efforts that can push timelines out by years.
Years. Wow.
It can happen. And think about the scale here. We're talking billions of users engaging with 3D content, a multi-billion-dollar market that's absolutely ripe for disruption. Disruption by platforms that can genuinely offer deep customization, unparalleled performance, and crucially, liberation from those often restrictive and complex licensing models tied to the big players.
Right, the licensing can be a killer too.
Definitely. And to illustrate, imagine that scientists needing ultra-high precision for, say, a fluid dynamics simulation.
Yeah.
They need exact, verifiable calculations, blood flow in an artery, airflow over a wing. Their demands for data accuracy are profoundly different.
Then a game developer needing cool explosions and combat physics.
Exactly. That game developer needs dynamic combat, particle effects, intricate physics for thousands of agents. A single general-purpose engine just cannot efficiently serve both those needs, not without immense, almost prohibitive customization effort and compromise on both sides.
So the monolithic model just fundamentally falls short there.
It creates this chasm between potential and reality for so many advanced 3D applications.
Okay, so this is where it gets really interesting. And yeah, quite revolutionary. Cadence isn't just offering a small improvement, it's proposing a complete paradigm shift.
Whole new way of thinking.
It's introduced as an AI-native, modular, and declarative engine generation platform, the core idea, to fundamentally return engine creation, engine control, back to the developers. So you no longer just use a pre-made engine, you actively define it, shape it, assemble it. For your specific game, your unique needs, your target audience. It sounds like getting a truly custom-fit tech stack every single time.
And if we connect that to the bigger picture, Cadence isn't just a new tool in the toolbox. It represents a whole new philosophy for interactive software development. It boldly positions the engine itself, not as some static, unchanging black box, but as a living part of the development experience.
A living part. What does that mean practically?
It means intelligent agents are deeply woven into every single stage, actively supporting creation, streamlining maintenance, relentlessly optimizing performance, continuously driving innovation. The vision is incredibly ambitious, really far-reaching, to build a self-evolving engine platform, one capable of simultaneously serving the demands of gaming, complex simulation, high-fidelity scientific visualization, cinematic production, all with unprecedented efficiency and adaptability.
Wow, serving all at once.
That's the goal. And the key outcomes here are transformative. We're talking reducing time to prototype from weeks or months down to astonishing minutes or hours.
Minutes or hours,
Yeah,
seriously.
that's the claim. And crucially, all those architectural decisions, every component, every configuration choice, it's all captured as code, what they call infra as code for engines.
Okay, like DevOps, but for game engines.
Exactly. It ensures repeatability, traceability. Your engine blueprint is as version controlled and manageable as any other code. Unparalleled consistency and reliability.
So at the heart of this Cadence revolution is something called the Model Context Protocol, or MCP. Our source describes it as an open standard defining how AI models, agents, and external tools exchange context, capabilities, and structured data.
Okay, that's a mouthful.
Yeah. For someone like us wanting to build something cool and cutting edge, what does this mean practically? How does it change how we interact with the engine?
That's a fundamental question, isn't it? And it really highlights the shift from how we currently interact with software to how we could. The MCP provides this sophisticated declarative context layer.
Declarative context layer.
Okay. So instead of developers calling rigid, predefined APIs that often force them down a specific path.
Yeah, the engine's way of doing things.
Right. You're now describing your intent through these highly structured schemas. Think of it less like a fixed instruction manual, more like a detailed design brief that an incredibly intelligent, compliant team then executes.
So you say what you want, not how to do it step by step.
Precisely. It functions as a capability bus, a standardized, flexible, open way for intelligent agents, AI models, various tools to discover, negotiate, and use agent capabilities, rendering, physics, asset management, AI behaviors. It all happens through clear contracts, not the often chaotic, ad hoc code integration and brittle interfaces we deal with today.
Less glue code and guesswork.
A lot less. It ensures every component knows exactly what to expect, how to interact, much more robust and scalable systems. And to get a bit more specific, the MCP is built on several core concepts that make this intelligent orchestration work. First, resources. These are essentially type surfaces for pretty much everything in the engine's world. Engine specs themselves, project assets, shaders, materials, even performance reports.
So, like, define containers for information.
Exactly. And what makes resources so powerful and key to Cadence's deterministic design is they enable content-addressed caching. Build the same thing twice. The system intelligently pulls from cache, speeds up iteration massively.
Smart. Avoids redundant work.
Big time. They also allow efficient delta diffing, only tracking changes, and crucially, ensure truly reproducible builds. Give it the identical MCP config and input resources, you are guaranteed the exact same output every single time.
That solves the "it works on my machine" nightmare.
Pretty much. Huge time saver, much more reliable deployments, especially for large teams. Then there are tools. These aren't just any functions, they're safe declarative commands. Think actions like build engine, validate determinism, make a nav mesh for AI pathfinding, or compile shaders.
Okay, high-level actions.
Right. By making them declarative and discoverable via MCP, they can run not just locally, but horizontally across a massive distributed network. Imagine orchestrating a shader compilation farm or a build farm spanning hundreds, thousands of machines, all managed transparently.
Whoa, like a build cloud for your engine?
Essentially, yeah. Radically enhances efficiency for large-scale stuff, letting projects scale compute resources on demand without complex manual setup. Prompts, next. They're all about reusability and consistency, defining powerful, reusable workflows. Instead of manually setting up every detail for a new project, you might just invoke a prompt like, generate voxel engine with Lua plus web GPU.
Like a template, but smarter.
Exactly. A template that provides policy-compliant scaffolding. It adheres to best practices, project standards, ensures consistency, and valuable for large teams and complex projects. Sampling is how AI gets safely integrated. It allows Cadence servers to ask a client-controlled large language model, an LLM, to synthesize code or configs.
So the AI can write code for you.
It can propose code, yeah. Auto-refactoring suggestions, generating gameplay templates, but the crucial part, addressing AI governance concerns.
Important these days.
Very. Is done with explicit user approval at every step. And importantly, the client holds the model keys, keeps usage data and AI interactions under strict governance and control. Privacy, compliance.
Good, so the user stays in control of the AI.
Absolutely. Roots define sandbox project boundaries. Cadence servers and agents operate strictly within predefined allowed file paths, vital for secure multi-tenancy in the cloud, compliant CI/CD environments, especially for enterprise stuff where security is paramount.
Makes sense. Keeps things contained.
And finally, elicitation.
Yeah.
Handles missing info intelligently, instead of just failing or forcing you into brittle UIs.
Yeah, cryptic error messages.
Right. Cadence uses structured JSON schema prompts to dynamically collect missing config details at build time. If a design brief needs soft shadow parameters you haven't specified, it'll ask you clearly, structurally.
So it asks for what it needs when it needs it.
Exactly. Makes the system much more robust, less friction for developers, much more user-friendly. Automates tedious manual steps.
Okay, so beyond these technical specs, Cadence clearly has this strong philosophy, these core beliefs that really seem to resonate with how creators want to work today. It's not just the tools, but the way you engage with creation. What are these guiding principles?
Indeed. And the vision document really highlights these pillars, which are fundamental to understanding Cadence's potential. First, AI-human co-creation. The philosophy is crystal clear. AI agents are not replacing humans, far from it.
Okay, that's good to hear.
They act as incredibly powerful accelerators. maintaining systems, generating insights, handling repetitive, boilerplate tasks. This deliberately empowers humans to focus on the truly creative, strategic, problem-solving aspects.
So AI handles the grunt work.
A lot of it, yeah. Next is declarative, not procedural, central to MCP as we discussed. Instead of writing rigid step-by-step procedural code, you express intent. You say what you want, real-time strategy game with procedural maps, and the system figures out the optimal how.
Letting the AI handle the implementation details.
Leveraging intelligent agents and underlying tech like Tellusim, yes. Then extensibility by default. This is a game changer. Every single system, every component, physics, rendering, scripting is architected from the ground up to be pluggable, modular, replaceable.
So you can swap parts in and out easily?
Seamlessly. Need a different physics solver for scientific accuracy. A novel rendering technique. Swap it in without re-architecting everything. No more wrestling the monolith. Cross-domain compatibility is another critical pillar, built from the ground up to adapt seamlessly between vastly diverse applications. High-octane games, high-fidelity cinematics, complex scientific visualizations, defense-grade simulations.
Handles them all.
That's the design. Directly addresses those underserved industries and the limitations of monolithic engines we talked about. Deterministic by design underpins reliability, a foundational guarantee. Every build, every generated engine is perfectly reproducible.
Same input, same output every single time.
Always. Ensures consistency, makes debugging simpler, vital for competitive games or scientific validation. And finally, autonomous evolution. Cadence envisions a future where engine maintenance, refactoring, integrating cutting-edge research.
Well, stuff that takes ages manually.
Exactly. It's baked into the engine's life cycle, handled autonomously by intelligent agents.
So the engine improves itself over time.
That's the revolutionary idea. A self-healing, self-improving platform without constant manual intervention. And to make that philosophy tangible, let's revisit that design brief example in JSON. You define experience goals, cozy or tense, mechanics, farming, exploration, art style, 3D, isometric. Then the power of declarative design kicks in. Cadence automatically translates these high-level goals into concrete technical requirements.
The translation step.
Right. Cozy plus 3D plus isometric might translate to rendering demands. Soft shadows, bloom low, stylized tone mapping.
And this is where Tellusim comes in strongly.
Precisely. This is exactly the kind of flexible, precise, visually rich rendering capability that a powerful substrate like Tellusim is engineered to deliver. It ensures the generated engine's visuals perfectly match the creative intent without compromise.
Okay, so Cadence builds these custom intelligent engines. Where does Tellusim fit into this grand vision? Our source describes it as a modern graphics and simulation engine SDK key to the Cadence platform. Sounds like it's providing some serious foundational muscle.
You've hit the perfect analogy there. Tellusim is exactly positioned as the high-performance rendering and simulation substrate that Cadence leverages. Think of it like the incredibly powerful, highly optimized engine block and chassis, around which Cadence builds its bespoke custom vehicles.
Yeah, the core power unit.
Precisely. Tellusim provides that cross-platform rendering and simulation backbone. It directly embodies and enables Cadence's vision of modular, AI-native deterministic engine generation. What's crucial is that by integrating Tellusim, Cadence is free to focus its power on its unique AI orchestration, the agents, the MCP framework.
It lets Cadence focus on the intelligence layer.
Exactly. All that intelligence sits on the shoulders of a proven cutting-edge rendering solution that already handles the most demanding visual and simulation tasks efficiently and with high fidelity. Tellusim provides the raw, optimized horsepower and specialized capabilities. Cadence focuses on being the sophisticated brain, designing and assembling the perfect machine.
That's a great analogy. Let's unpack that horsepower then. Sources highlight Tellusim supports basically every major graphics API. Vulkan, Direct3D, 1211, Metal, OpenGL, OpenGL ES, even WebGPU, WebGL. That's an incredibly broad range. What does that mean for a developer using Cadence? Consistency, reach.
What's truly fascinating and a huge advantage is Tellusim doesn't just support these APIs separately. It provides a unified low-level model that abstracts and harmonizes them.
Unified. So one way to talk to all of them.
Effectively, yes, from Cadence's perspective. It means Cadence's MCP can declaratively select the right rendering backend for any project. High-end PC game. Cadence configures Vulkan via Tellusim. Apple Vision Pro app, it selects Metal. Web-based visualization, seamless web GPU integration.
Wow, handles all that automatically.
That's the power. It enables truly reproducible builds across this incredibly diverse array of platforms, Windows, Linux, macOS, iOS, Android, web, without needing significant platform-specific re-engineering or manual porting.
Huge time saver. No more writing separate render paths for each platform.
Exactly. This cross-platform consistency is crucial for Cadence's early phases, mentioned in its Strategic Technical Plan Phase 0 and 1. Ensures fundamental rendering consistency and broad market reach right from the start.
And it boasts a GPU-driven scenograph and animation system, designed for minimal CPU load and rendering millions of dynamic objects efficiently. That sounds like serious performance, especially for those large-scale simulations we mentioned that choke traditional engines.
This is precisely where Tellusim truly differentiates itself, especially for large-scale simulation and visualization. It fundamentally moves beyond the CPU-centric approach of many older engines. Its architecture is built from the ground up to leverage modern GPU capabilities, techniques like bindless resources, meshlets, compute rasterization.
Okay, technical terms there. Bindless resources.
A meshlet.
Mesh.
Right, quickly. Bindless resources let the GPU access all needed data textures, buffers directly, efficiently, less CPU babysitting, huge overhead reduction. Meshlets are optimized small clusters of triangles. The GPU processes very efficiently, great for detailed models. And compute rasterization uses the GPU's general compute power for rendering, bypassing older fixed pipelines for more custom, efficient rendering.
Got it. Advanced GPU tricks for speed.
Exactly. These allow Tellusim to handle truly massive data sets, think vast city environments, complex scientific models, military sims with tens of thousands of entities, all with incredible efficiency, minimal CPU impact. For Cadence, this means unparalleled scalability. The builder and overseer agents can plug Tellusim's GPU-driven traversal directly into ECS architectures.
ECS being Entity Component System, good for lots of objects.
Right. This integration maintains determinism across incredibly complex scenes and scales rendering performance effortlessly as complexity increases, critical for advanced simulations.
And it has all the modern rendering bells and whistles. Ray tracing across DXR, Vulkan RT, Metal RT, configurable PBR pipelines, deferred, forward, order-independent transparency. Sounds like it can achieve absolutely top-tier visual fidelity.
Absolutely. These features deliver stunning visuals, but they're also critical for enabling innovation within Cadence. Tellusim's modularity here means Cadence's researcher and spearhead agents, the AI exploring new tech, have a robust substrate for testing and integrating emerging algorithms.
Like what kind of algorithms?
Think neural global illumination using AI for realistic lighting or optimized async schedulers for GPU workloads. These agents can push the boundaries by leveraging Tellusim's capabilities, ensuring Cadence-generated engines stay at the forefront of rendering tech. Plus, configurable PBR means tailoring the look from photorealism to stylized.
And order-independent transparency.
Right. Yes. OIT is a technical marvel. Lets complex, transparent effects, smoke layers, intricate glass, water render correctly regardless of drawing order, eliminates common visual bugs, makes visuals much more believable, vital for games, and accurate scientific visualizations.
Okay, this next one sounds huge for non-gaming uses. Native CAD model support and 64-bit precision. What does that unlock, especially for professional and scientific fields?
This feature is absolutely monumental for cross-domain adaptability. A key differentiator highlighting Tellusim's unique value. Traditional game engines like Unreal, Unity, they usually require CAD models the kind engineers use to be painstakingly triangulated, converted into game meshes.
Which can lose detail, right?
Often loses precision, introduces artifacts. Plus, those engines typically use 32-bit floating point precision, less ideal for engineering, GIS, rigorous science, where direct lossless CAD ingestion and full 64-bit floating point transforms FP64 are essential for millimeter accuracy, scientific validity.
So Tellusim handles the original CAD data directly, with high precision.
Natively supports them? Yes. Instant CAD loading, no error-prone triangulation, full 64-bit precision. This aligns perfectly with Cadence's expansion into medical, defense, scientific simulation domain packs. Directly enables those industries to build incredibly accurate, real-time visualizations from their source engineering data, no compromises.
It also supports a rich plugin ecosystem. Upscalers like DLSS, XSSS, FSR23, procedural terrain, planetary rendering, Gaussian splatting, physics engines like Physics, Jolt, Bullet, Box2D, even XR modes like Multiview and OpenXR. That's a ton of functionality out of the box.
This deep plug-and-play capability is central to the whole MCP vision. Tellusim provides this comprehensive catalog of configurable toggles and modules within Cadence's marketplace. As a developer using Cadence, you declaratively enable or disable features based on your project's needs. Need ray tracing? Check. CAD support? No problem. Specific physics engine.
Like Box 2D for a 2D game, physics for complex 3D.
Exactly.
Yeah.
This dynamic selection, orchestrated by Cadence's AI agents, allows highly specialized engine configurations generated on the fly, ensures the resulting engine is perfectly optimized, free from bloat, equipped with exactly what you need, reduces dev time, boosts efficiency, instant access to cutting-edge features.
And from robust asset pipeline support, USD, GLTF, FBX import with GPU compression, to multi-language bindings for C++, S, C#, Rust, Python, Swift, Java, Kotlin, Tellusim seems to cover all integration bases.
This comprehensive support ensures Cadence, leveraging Tellusim, remains open, flexible, broadly accessible.
Wow.
Generated engines aren't isolated islands. They integrate easily with teams using their preferred languages and existing asset pipelines.
Handle standard formats like USD, GLTF, FBX smoothly.
Yes, even offering GPU compression. This flexibility reinforces Cadence's core strategy,
Yeah.
maximizing developer agency. Teams incorporate generated engines into existing toolchains without friction, minimizes learning curves, maximizes productivity.
So just to reiterate, Tellusim isn't another engine competing directly with Unreal or Unity. It's a specialized foundational component. How does it truly stand apart from those monolithic engines? What are the core differentiators?
A critical distinction. And it brings back that question. Why not just use Unreal or Unity? The source positions Tellusim as a precision-engineered graphics and simulation substrate, foundational tech for deep integration. Key differentiators. First, low-level control. Tellusim offers granular control interacting directly with graphics APIs, unlike the heavy abstraction, black box nature of monoliths. Greater optimization potential, specialized techniques easier. Second, GPU-driven scalability. Purpose-built for massive datasets, GPU-driven scenographs. While Unreal Unity handle complexity, they're comparatively more CPU-centric for vast object counts. Tellusim's raw GPU power is engineered for extreme simulations, billions of polys, millions of objects, a league apart.
So built for scale from the start.
Fundamentally. Third, native CAD 64-bit precision. As discussed, a niche where Tellusim uniquely excels. Traditional engines struggle, need workarounds. Tellusim's native support is a game changer for engineering, GIS, science. Fourth, lightweight and embeddable. A compact SDK designed for deep integration, perfect for Cadence's modular approach. Contrasts sharply with massive, rigid runtimes of competitors, hard to embed or customize deeply. Fifth, cross-platform consistency. Engineered for easier, consistent, deterministic builds across Windows, Linux, Mac OS, iOS, Android, web. More unified, predictable dev experience than sometimes divergent pipelines of monoliths. Sixth, stress-tested at scale. Proven with benchmarks like GravityMark handling billions of objects. Real-world validation of raw GPU scalability beyond typical gameplay scenes. Robust for extreme workloads. And finally, flexible licensing. Small team-friendly negotiable terms. Vital for an open ecosystem like Cadence. More freedom and cost predictability than rigid royalty-based models. Empowers more developers.
So, if I'm getting this right, Tellusim lets Cadence compete immediately on raw performance and a critical cross-domain adaptability. Meanwhile, Cadence itself focuses fully on its unique strengths: the AI orchestration, declarative design, agent-driven modularity. Tellusim gives Cadence a massive head start technically.
Exactly. It's deeply symbiotic, designed for maximum impact. Tellusim provides the raw horsepower, cutting-edge rendering, specialized features like KEFP64. This lets Cadence focus entirely on its unique differentiators: the sophisticated MCP schema, AI-driven generation of bespoke evolving engines, the intelligent agent ecosystem.
A powerful combination.
It ensures that generated 3D tech isn't just fast, customizable, scalable, but also perfectly aligned with the nuanced demands of complex interactive experiences. Games needing split-second reactions, scientific visualizations needing absolute precision, high-fidelity training simulations. Together, they're an incredibly potent force in 3D creation.
Okay, let's bring all these incredible pieces together now. How does this AI-driven, Tellusim-powered system actually work in practice to rapidly build any kind of interactive 3D experience? Walk us through that high-level pipeline, from just a basic idea, a concept, all the way to a playable prototype ready for iteration.
It's an exquisitely designed, end-to-end automated pipeline, meticulously governed by the Model Context Protocol at every single stage. It all kicks off with a design brief intake. You, the creator, start by providing a structured design brief. Describe your intended player experience feelings, pacing, fantasy, core mechanics, genre, target platforms, constraints.
So you tell it what you're aiming for.
Exactly. For a vivid example, let's use Whisper Grove from the source, a cozy farming and exploration sim. Its brief might define experience goals like cozy and relaxing, constraints like target FPS, 60 for Shiv deck, aesthetic preferences like isometric camera, 3D stylized art. This structured input sees everything. This design brief then flows into the tech requirement synthesizer, a crucial intelligent step. It translates those high-level, often subjective goals into concrete, actionable technical requirements for every aspect of the engine: rendering, physics, AI, audio, UX.
Turning cozy into technical specs.
Precisely. For Whisper Grove, cozy plus 3D plus isometric translates into rendering needs. Soft shadows, bloom low, stylized tone mapping. Farming plus crafting generates needs for inventory system, grid-based terrain tools, dynamic time system for crops, and day-night cycles.
And Tellusim provides the means to achieve those rendering specs.
Directly instrumental here. Tellusim's configurable PBR pipelines, advanced lighting. They provide the underlying capabilities to precisely fulfill these specific rendering requirements. Ensures the generated engine manifests the vision perfectly. Next, the Engine Configurator MCP. This is where core architectural decisions are intelligently made for your bespoke engine. Based on the synthesized tech requirements, it chooses the most suitable engine pattern, maybe ECS for many entities, component-based or hybrid. Adapts dynamically.
Picks the right structure for the job.
Right. It then composes an engine blueprint that infrastructure as code file for your engine. Specifies core patterns, optimal rendering APIs, leveraging Tellusim, maybe Vulkan for desktop, WebGPU for web, ideal physics providers like Lightweight Box 2D for Whisper Grove, scripting languages like Lua for modding.
So it builds the engine's DNA file.
Effectively, yes. Finally, the Skeleton Game Generator takes this blueprint and, astonishingly quickly, produces a runnable prototype with stub assets. Not just an empty shell, a functional basic version of your game.
Runnable right away.
Yes. Auto creates necessary ECS components. Transform, sprite model, physics body, scaffold systems, render system, physics system, time system. Generates basic scenes, loading screen, test map, scripting hooks, Lua, basic UI. This is where the core engine, dynamically configured by Cadence, powered by Tellusim's rendering, truly comes alive. A playable prototype in minutes or hours, ready for immediate iteration.
Okay, going from idea to runnable skeleton that fast, that's a massive acceleration. But a game needs a rich world. What about the content? Models, textures, sounds, levels. That's where AI and procedural generation step in to populate this world, right?
Absolutely. And this is where the Asset Registry Mapper MCP is critical for intelligent content creation. It bridges the gap, intelligently translates high-level game feel and mechanics into concrete asset requirements. The process is smart. First queries existing pre-built asset libraries, your teams, licensed marketplaces.
Tries to reuse existing stuff first.
Right. But if specific assets are missing, it auto-generates detailed asset request definitions, ARDs. These ARDs are intelligently delegated, sent to specialized AI asset generation MCPs, text-to-3D model generators, text-to-sound synthesizers, text-to-animation tools.
AI making assets on demand.
Or, if deterministic assets are needed, delegated to procedural generation MCPs for terrain, dungeons, parametric models, ensures unique yet consistent outputs. For a Whisper Grove, farming might map to HOTOOL model crop models and invoke a terrain Gridgen v1.2 procedural generator for the landscape. Crafting might trigger an AI gen prompt. Stylized Madrigal crafting table with glowing runes, matching the aesthetic.
Combining AI, procedural, and pre-made assets.
Exactly. All these assets pre-built, AI-generated, procedurally crafted, are stored securely in a central asset registry. Rich metadata, provenance, prompt, license info, transparency, and compliance. This hybrid sourcing ensures consistency, determinism, incredible scalability for content creation. Every asset traceable back to gameplay intent.
And Tellusim renders all these different kinds of assets efficiently.
Yes. Regardless of origin, they benefit from Tellusim's GPU-driven pipeline, advanced graphics. Brings the vibrant, customized world Whisper Grove or anything else to life with stunning fidelity and performance.
That's a truly comprehensive content pipeline. Okay, so we have the prototype, the generated assets. How does it actually get out into the world for testing? And just as importantly, how does it keep evolving, given AI can manage so much now?
The whole process is remarkably streamlined, fully automated, designed for continuous iteration. The packaging and deployment MCP orchestrates getting the prototype out, automates builds, manages versioning, handles publishing, generates build files, CMake presets, embeds asset cook steps, platform-specific texture compression, wraps, platform SDKs.
So builds for Steam, desktop, web.
All handled, whether it's Steam, desktop, or web, using Mscripton and WebGP, WebGL, which Tellusim robustly supports. The source even shows CI jobs for automated Steam uploading. Enterprise ready.
But it doesn't stop at deployment.
No, that's where the continuous iteration loop truly kicks in. The telemetry plus feedback MCP is critical. Collects granular runtime metrics from playtests, frame timings, RAM-for-RAM usage, network RTT, design feedback from surveys, playtest notes.
Capturing real player data.
Vital data. These design deltas aren't just reports for manual analysis. They're intelligently fed back into the tech requirement synthesizer or the game design MCP. This intelligently closes the loop, allows the engine and game to literally self-tune and self-evolve.
Self-tuning based on player data.
Exactly. Based on real-world data, the system automatically proposes and implements changes, promotes best-performing ideas to higher fidelity peers, relentlessly optimizing the experience. And Tellusim's efficient rendering and scalability provide the robust foundation for gathering that accurate performance telemetry, crucial for powering this intelligent self-tuning loop.
One of the most fascinating, maybe counterintuitive features is exporting these prototypes to other engines, Unreal, Unity, Godot. Why is that so important if Cadence builds its own custom engines? Seems contradictory.
Excellent question. It speaks to a crucial strategic decision: maximizing developer familiarity, expanding ecosystem access. The external engine integrator MCPs translate Cadence's internal engine blueprint and assets into native project formats for those mainstream engines.
So you get a ready-to-open Unreal project, Unity project?
Exactly. A .upproject.unityproject.godot file. Teams can seamlessly continue iterating in their preferred IDEs, leverage existing plugin asset marketplaces, smooths onboarding hugely, reduces friction for adoption, allows gradual transition.
Okay, that makes sense for adoption.
But what's even more powerful, truly revolutionary for cross-platform dev, is the reverse integrator MCP. This advanced agent can actually import existing projects from Unreal, Unity, or Godot.
Import from them, wow.
Yes. Intelligently normalizes them into Cadence's canonical project CPJ format, a standardized, engine-agnostic internal representation, can optionally infer a design seed or design brief capturing the original intent. But here's the kicker. It can then re-emit that project into an entirely different target engine.
Wait, import a Unity project, re-emit it as Unreal?
Theoretically, yes. Enables unprecedented cross-engine portability. Allows true round-trip iteration. Engine-side edits made elsewhere can be re-ingested back into Cadence's central asset registry, design balance specs.
That breaks down traditional engine silos completely.
An incredibly flexible, adaptable, future-proof workflow.
We touched on the design brief, but Cadence seems to go even further with the game design MCP, generating structured design concepts from raw, vague idea seeds, like giving it a kernel of an idea and it fleshes out a whole design doc.
Precisely. Truly transformative. Converts subjective, abstract creative input into actionable, structured design. Feed it a design seed, newspaper snippet, random word, AI prompt plus genre modifier plus random twist. Example, rising sea levels threaten coastal city plus roguelike plus 1920s noir setting.
Okay, intriguing mix.
The GDMCP parses themes, applies genre templates, permadeath procedural maps for roguelike, maps desired feelings to mechanics, pacing curves, emits a comprehensive design concept and a normalized design brief for the rest of the pipeline, includes aesthetic guidelines informing the asset mapper.
And again, Tellusim helps realize those aesthetics.
Perfectly poised. Tellusim's varied rendering, stylized tone mapping, soft shadows, atmospheric effects can realize the diverse aesthetics dictated by these AI-generated concepts, ensures visual fidelity matches artistic direction.
Now, game balance. Notoriously hard. Countless hours of manual playtesting, tweaking. How does Cadence tackle this with AI? Make it more efficient? Objective.
The Balance MCP is explicitly designed for this formidable challenge, transforms it from art into more precise science, doesn't rely on human intuition alone, runs extensive AI agent playtests, sophisticated Monte Carlo simulations, rigorously evaluates balance across a vast parameter space.
Simulating thousands of playthroughs.
Essentially, yes, assesses critical metrics, win rates, churn points, time to kill, resource scarcity in the economy. Based on this deep analysis, produces balance patch, diffs, proposed changes against the balance spec, with clear data-backed justifications, guardrails.
So it suggests specific balance changes.
Yes. Example, if AI tests show too many early deaths from oxygen starvation and noir rising, it might propose reducing oxygen decay or adding more O2 tanks. Integrates seamlessly with the telemetry MCP for continuous data-driven tuning. Ensures games stay consistently fun, challenging, fair, reacts dynamically to how players actually play.
So clearly not just a one-off generation, it's a continuous self-improving cycle, constantly refining the game and its engine.
Exactly. The essence of the automated prototype lifecycle pipeline. An end-to-end self-optimizing loop. Continuously auto-generates novel prototype ideas, builds, deploys them for playtesting, captures feedback telemetry, intelligently promotes best performers to higher fidelity tiers. Starts with the auto idea generation MCP. Registry where mines asset registry embeddings, external seeds, generates ranked design seeds with feasibility scores.
Ideas with potential ranked automatically.
Then, prototype and tech generation leverages Tellusim for robust rendering, scaffolds the engine systems, build, package, and deploy. MCP automates optimized builds, deploys to Steam playtest, web, internal device pools. Feedback and telemetry capture MCP collects granular data, frame timings, input heat maps, session-length UX surveys.
Rich data feeding back in.
Feeds directly into the scoring and ranking MCP. Uses sophisticated multi-objective scores. Retention, satisfaction, performance, ranks ideas objectively. When predefined conditions met, say, retention and 25% FPS 455 on Steam Deck, the Fidelity Promotion MCP triggers.
Promotes successful prototypes.
Intelligently. Requests higher fidelity assets, AI gen, procedural, curated, enables more advanced render features, which Tellusim provides, like complex lighting particles, deepens animation trees. This entire feedback loop ensures continuous intelligent evolution of game and engine, pushing quality and engagement forward autonomously.
And even monetization. Complex, ethically fraught, addressed by AI, ensuring consistency with player experience, core mechanics, and crucially, ethics. Sounds incredibly challenging to automate.
Indeed. And you highlighted the crucial ethics aspect. The monetization MCP aims to be a comprehensive, responsible solution. It generates a full strategy, emits economy specs, currencies, source asyncs, catalogs, IAPs, wires, storefront SDKs, closes the loop with telemetry balance for optimization, critically enforces ethics and compliance in code, rules like no pay to win, competitive advantage can't be bought, transparent odds disclosure for loot boxes, age gates, regional restrictions for global compliance.
Building ethics right into the system.
That's the goal. It can generate currency packs, cosmetics, battle passes, even A/B test pricing, all while ensuring the underlying engine and assets often rendered with Tellusim's fidelity support these features and deliver on the core design intent without compromising player experience or trust. Hashtag tag, shag tag outro.
Wow. What an incredible deep dive today. We've really gone from grappling with those old monolithic engine limitations to embracing this revolutionary future where AI platforms like Cadence, powered by high-performance tech like Tellusim, can build and evolve bespoke 3D experiences. In hours, not months. It's a vision promising just unprecedented creative agency and technical precision for anyone working in interactive 3D.
And if we connect that to the bigger picture, this profound shift fundamentally changes the entire landscape of interactive software development. It truly democratizes engine creation, makes sophisticated tools accessible to a much broader range of creators, not just the huge studios.
Levels the playing field a bit.
A lot, potentially. It enables massive AI-assisted creativity, unlocking new possibilities for content generation, iterative design, rapid prototyping, and crucially, allows complex systems to autonomously optimize and adapt across this incredible range of domains. Games, scientific visualization, defense simulations, the symbiotic combination of Cadence's declarative design and a powerful, adaptable rendering substrate like Tellusim. It truly creates this dynamic operating foundation for creative and scientific expression in real time, pushing boundaries constantly.
Indeed. So what does all this mean for you listening? As a creator, an innovator, or just someone interested in the cutting edge, it means that traditional line between a finished game and its engine, it's not just blurring, it's actively dissolving. It signifies the potential for rapid, highly customized, infinitely adaptable 3D interactive experiences is just exploding right now. It's a future where the engine itself is, in a way, a living entity, constantly learning, evolving, optimizing alongside your creative vision.
An engine that grows with the project.
Exactly. So the next time you encounter a stunning, perfectly tailored 3D experience, one that feels uniquely crafted for its purpose, you might just be looking at a system that, in a very real sense, built itself.
A fascinating thought.
Something truly profound to mull over until our night's deep dive.